Welcome friends, welcome back to our channel Crystal Learning. So today the subject is fluid mechanics and we will see the concept of Froude number and open channel flows, and this question came in SSC-JE Mechanical 2017. So what happens many a times, as a student we try to mug up the answer, and as we it is said that brain has unlimited capacity, but we are able to use little bit of that capacity, and in that too, if we are putting garbage inside the brain, so the space become less for learning the concept. And because this is not the way to study any subject, without knowing the concept just try to mug up the answer, because there can be many numerical problems on concept can be framed from the subject from the same topic with changing the sentence or giving some twist. So how much question you will mug up? So there is a limitation for that. So it is always said that try to learn the concept, and then on that concept if there is any twist or anything, then you can easily apply and you can solve new problems also. So in that series we will see what is Froude number and what is the physical significance of that. By saying less than 1, then the flow is called answer, you know, subcritical, you will get marks. I'm not saying that you won't get marks, but suppose there is some twist in this question, or in interview it is asked that what is the physical significance of Froude number, explain Froude number with respect to subcritical flow, supercritical flow, then there is no answer. For that we will study today. So what happens? It is asking that Froude number in open channel flow is less than 1, then the flow is called subcritical flow. So in that regard, suppose there is a still water and you throw a stone in that still water. So we know that wave will be generated. We have done this, okay, in circular form, in outward, in propagate outward in form of concentric circle. Okay, so we know this is the shape. You throw a pebble here and it will travel in concentric circle in still water. V is 0. So now we will define a term that is celerity. What is celerity? The speed with which disturbance propagate. We know this disturbance are propagating outward. So what is the speed of that propagation? That is itself known as celerity, or celerity of gravity waves in shallow water. And that formula is given by C equal to under root GD. G is gravitational acceleration and D is hydraulic depth and C is celerity. Sometimes what happens, it is used at wave velocity and water velocity, so there might be a confusion. To remove that confusion, wave velocity is often referred as wave celerity to avoid the confusion. From that word we know that what is celerity, that is wave celerity or speed of the disturbance which it propagates. Okay, so now we have seen that there will be concentric circle when velocity equal to 0. But when the water is moving with a velocity v and then we throw the stone in that body, water body, then what will it happen? So this case was studied by the scientist, that is William Froude, and he gave the number as Froude number, or later that number was known as Froude number, to define or differentiate between the flow, that is it is subcritical flow, supercritical flow or critical flow. How you will differentiate between this flow in a channel or open channel. So that number is known as Froude number. So it is defined as the ratio of stream velocity to the wave celerity. Stream velocity v divided by wave celerity. Earlier we used to just note this number, this formula v by under root gd without knowing the physical significance. So under root gd is c, that is wave celerity v by c. So now let's see three cases what will happen. So in still water it is over with velocity c in this direction and velocity c in this direction. So suppose we are asking for critical flow. In critical flow we know that Froude number is equal to 1 or equal to 1, then v equal to c. So upstream velocity from the point which you have thrown, so in backward direction you see that c minus v equal to becomes c minus c equal to 0. So no upstream, means from this point the wave is not propagating backward or upstream, it is only propagating in downstream direction with a velocity of 2c. That forward direction is v plus c, because water velocity in forward direction v and wave velocity is c, that will get added up, so it will be v plus c or 2c. So this is the case of critical flow. Now what will happen in subcritical flow? In subcritical flow, we know it is Froude number is less than 1. So in less than 1, what happens? V less than C. So in backward direction, we know C velocity is C minus V, because in this case C is greater than V. So the case will be C minus V. In forward direction, it is C plus V. So this C plus V is greater than C minus V. So we see the shift of this wave propagation is more in downward direction and less in upstream direction. Okay, but it is traveling upstream, means some wave will propagate in upstream direction also. So now the next case is supercritical flow, that is greater than 1. V by C is greater than 1 or V greater than 1. That flow velocity or river velocity is very high in respect to wave velocity. In that case, V is greater. So backward this point will travel with V minus C and forward is V plus C or C plus V. Okay, so this is the case, means in this supercritical flow the wave won't propagate upstream. Okay, it will propagate only in downstream direction. Okay, so we see that this was the case in all the three flows. So let's study some sentences so that it will become more clear. So what is happening in subcritical flow? That is, subcritical flow is less than 1. That means velocity of water body is less than that wave velocity. So when bottom slope is small, so it is saying then when bottom slope is small, so the flow velocity is relatively low. Why? Because of the small gravitational driving force is acting on this flow. So it is slower than the celerity of the wave generated by the disturbance. Such a flow for small slope is called subcritical flow. Therefore, flow is subcritical, the disturbance will propagate. Now the disturbance will propagate upstream also and downstream also. Okay, upstream means backward direction or opposite direction of the velocity, known as upstream, and downstream is the direction along with the velocity of the river. So this is the case we have seen in the diagram also. Now the next case is supercritical flow, that is fr greater than 1. Here we got velocity of flow is very greater than the wave velocity. So as the bottom slope increases, you just increase this slope. Okay, you just increase that slope, then what will happen? That will increase the driving force or acceleration due to gravity will increase. Okay, acceleration due to gravity. When the bottom slope is sufficiently steep or large, the flow velocity exceeds the wave velocity and flow is called supercritical flow or analogous to supersonic motion of a fast flying object. Okay, so in supercritical flow, disturbed waves are swept downstream. Whatever waves are generated, that will be swept by the fast flow river and cannot travel upstream. That upstream they won't able to travel the disturbances. We have seen in the figure also. Therefore, if a flow is supercritical, then propagation will be in downstream direction only. So propagation will be in downstream direction as shown in the figure, with back and the front edges moving with a speed of v minus c and v plus c respectively. Third case is critical flow. In critical flow, velocity of the river becomes equal to the disturbance velocity, propagation velocity c, and this in this what happens? The upstream edge of the wave will remain stationary, while the downstream propagation will be at a speed of 2c. So it is saying upstream edge. Whatever the upstream edge means, you have thrown the pebble here or the stone here, and you see the disturbance are being traveling in forward direction, and this upstream or the back edge of this whatever disturbance is remaining stationary. So these are the all three cases, and this reference is being taken from A. Osman A. Khan, Open Channel Hydraulics, very good book. I want to personally thank all the authors who are giving such nice explanation in their books. By reading these books, we are able to get some new concept and a better understanding about this Froude numbers and all the concepts. So I personally thank from my heart to these authors. Okay. So I hope you enjoyed this lecture, and the concept of the Froude number of physical significance of the Froude number, how it is being applied in open channel flow is clear now. So meet you next time with a next lecture with a new concept. Till then, have a nice day.